This is going to be a little bit of a review from last year and hopefully be a piece of cake. All right, so linear systems with graphing, we are going to approximate them. We're going to solve them exactly. We're going to focus on pairs of linear equations, two variables. We're going to do some graphing. We're going to do some substitution. We're going to do some elimination. All kinds of fun solving these. All right, first, what is a linear system? It's when we have two or more linear equations with the same variables, okay? Meaning that the variables are going to represent the same items in both equations. And in this case, we're going to plot them both on the same graph. So let's first talk about what the solutions are going to look like and what they mean, okay? So the first thing I want you to do is I want you to take each of these points and I want you to plug them into both of these equations to see if they work, okay? So what you're trying to find is which point, A, B, C, or D, or maybe it's none of them, can you plug into both equations and have it work? So go ahead, pause the video, and you try doing that now. All right. Well, hopefully after plugging them in, you found that D was the correct answer, right? When you plugged in 1 for x and 5 for y, I've got negative 5 times 1 is negative 5. Negative 5 plus 5 is going to be equal to 0. Then if I do it again here, and I plug in 1 comma 5, if I do 5 times 1, I get 5, plus 5 is equal to 10, so that checks out. Both of them work. Okay, so 1 comma 5 is a solution. Now you might have gotten one of these, maybe one of them worked for let's see, like negative 1, negative 5 works for the first one, right? Here, so if I plug in negative 1, I get 5 plus negative 5, that equals 0. But it's not going to work here necessarily, so 5 times negative 1 is negative 5 plus negative 5 is actually negative 10, okay? So what does that mean? What does it mean when we actually, what does that solution mean here? So it means this point is actually on... It means this point is on both of these lines, okay? In fact, it's where these lines are going to intersect. So this solution, where x is 1 and y is 5, works for both of these, okay? It's a point on both lines. All right, so let's take a look at what this looks like, okay? So here I have negative 5x plus y equals 0 and 5x plus y is equal to 10, okay? And we're going to go ahead and graph these. So I'm going to use, since these are written in standard form, I'm going to try using intercepts first, okay? Because I have 0. I think I can pretty much find the intercepts here. I have 5 and 1, right? These are my coefficients. 10 is divisible by both 5 and 1, so I'm going to use intercepts there. So the red one I'll do in red. So let's see, my x-intercept. So negative 5 times, so x is going to be 0. Okay. And y is actually going to be 0 also. So I'm going to have to adjust a little bit. In fact, let's go ahead and plug in. We know that if x is 1, right? If x is 1, then y must be 5. 1, 2, 3, 4, 5. Okay. Right? If I just plug in 1, negative 5 plus 5, that's how I get to 0. Okay? So there we go. There's that line, and we'll go ahead and I'll draw this out. And we'll make sure that we go through here. And that's pretty good. It's not perfect. Let's try to... There we go. Okay, next, let's do the blue one. Okay, so this is going to be 5x is 10, so x is going to be 2. And y will be 10. Well, that's not going to fit on here, so let's try if we know if x is 1, y is 5. So if I go 1 comma 5, okay, and then the next one would be 0 comma 10. And I can go ahead and I can graph this. And we'll notice that when those two lines intersect at 1 comma 5, which we already knew because we had solved, we had done that before, but this would be the solution to that system of equations. Okay, it's where they intersect, it's where both at 1 comma 5, both of these equations are true. All right, well, let's move on. Let's try one more here. I've got 2x plus y is equal to 4, and I've got negative x plus 2y is equal to 3. Why don't you go ahead and you try to draw, graph each of those lines independently, and then we'll look to see where they intersect, if they do, and we'll find the solution. So why don't you go ahead and graph those. Go. All right. Let's see, how are we going to solve this, or how are we going to graph this? So, we have a couple options here. We can do, we have standard form, so we can use intercepts, or we can use slope-intercept. In this case, I've got 4, right? Well, I can divide that by 2 and by 1, so I'm going to use intercepts there. So if I look at my intercept, 2x is equal to 4, so x is going to be equal to 2. And then my y-intercept is just going to be 4, so 1, 2, 3, 4. All right, and then I have my line, so it should start up about here. We'll draw it down through. Okay, and I'm going to try to draw as far across the graph as possible. Okay, next I've got negative x equals 2y is equal to 3. Well, I can use x, I can find that intercept pretty well, but 2 times what equaling 3, that's going to be a fraction that does not look very friendly to me. So I'm going to just go ahead and put this into, actually, okay, as I stutter here. I could put it in slope-intercept form, but I'm going to notice here that my intercept is actually going to end up being a fraction, right? It's going to be 3 halves. So I can either put it at 3 halves, or, what I'm going to try doing is I'm going to plug in, I'm just going to use -1. So if x is -1, okay, I'm just going to, it's sort of like I'm doing kind of an input-output table here, right? So if x is -1, then what's y got to be, right? So it's going to be 1 plus 2y is equal to 3. So y is going to be equal to 1. Okay, so if I subtract this, 2y is equal to 2, so y is equal to 1. I said 1 plus 2 is equal to 3, so y must be 1. So this is so it's -1, comma 1. So I'll do that. I'll go -1 and I'll go to comma 1. All right, and now I need another point. So let's just look at the intercept. So 0, if this is 0, negative what is 3? Well, that'll be -3. So I'm going to go ahead and go to -3. Okay. And now I'm going to go ahead and draw my line. Got it in red. That's good. Let's go ahead and draw this through, nice and long. And I'm going to look to see where this crosses, and it looks like it intersects right here at 1, comma 2. Okay, and let's go ahead and plug this in and make sure this works. So 2 times 1 is 2, plus 2 is equal to 4. That works. -1, okay, so -1 plus 4, does that equal 3? It does. So my solution is 1, comma 2. All right, and there you have it. Systems of equations graphing. When you guys come back, next time we meet, we'll go ahead and do some practice. I'll let you guys do a lot more graphing, and I have full confidence you guys will be great at it. Okay.